Hi, Srivali.
Hi, Shanti.
In today's discussion, as we planned, let us discuss about the chatbot development for IT support. Okay. So the activity is here: design and implement chatbots using Azure Bot Services and Azure Cognitive Services to handle common IT support queries, freeing up human resources for complex issues. You have experience in production management also, right, in the past, and
Yeah.
change management process. So you know
Mm-hmm.
the complex issues, how long it takes to solve them also. Okay. The
Mm-hmm.
relevant skills are here is required for development of the chatbot is proficiency in generative AI, prompt engineering, and Azure Cognitive Services. Okay. Now, continuation of this one is the design solutions are designing a data setup for a chatbot that handles IT support queries using Databricks under Azure ML involves several steps. Here is a structured approach to achieve this. First, we need to define the use cases and requirements. So, identify common IT support queries, example, password, reset, software installation, network issues. So, okay. Then determine the expected volume of queries and peak times for usage. Establish the performance metrics for chatbot. Okay. So you have to identify one particular application. Okay. You take e-commerce application itself. We have worked extensively with e-commerce application. Okay. From
Mm-hmm.
migration to Azure ML and some of them with generative AI solutions also. Okay. If you take that application, then there will be queries also for different modules, right? Right. We'll figure out that what application we can use in that case. Okay. Then what are the data sources? Historical support tickets. Collect data from previous IT support tickets to understand common queries and resolutions. See here, chatbot needs some kind of data.
Mm-hmm.
Okay, we need to build that particular data. Okay, like past incidents, issues, such kind of things. The knowledge base articles gather documents or articles that provide solutions to common issues.
Mm-hmm.
So when you have the documents, that documents are going to be a knowledge base for the chatbot.
Mm-hmm.
It is going to be trained on that content also. The chatbot is going to be trained under ML activities, right? Then
Mm-hmm.
user feedback. If available, include data from user feedback on past interactions. Okay.
Mm-hmm.
Now, data preparation in Databricks, what it is required. Data ingestion is the activity. Use Azure Data Lake or blob storage to store historical support data. You can use Databricks to read and process this data. Okay. It all depends on if you are using a database. Yes, that database connectivity can be given there. If you are using a Excel data or test files, so then you need to use blob storage. We need to figure out using the data lake area that process for configuring the data bricks to pull the data, right? Then
Yeah.
data cleaning is clean the data to remove duplicates, irrelevant information, and ensure consistent formatting is there. Okay. Then data transformation is convert the test data into a suitable format for training. Yes. So we have worked with the feature engineering also. We have modified some data with some kind of comments or something. It depends on the category of the feedback in the past.
Mm-hmm.
Okay. So feature engineering is what creates features and that represent the queries and responses effectively, such as query type, categorical variable, keywords, bag of words, TF or IDF or something. So we worked on these things also in the past demos, you know that. So model training with Azure ML is generative AI models involves leverage pre-trained models from Azure Cognitive Services like OpenAI's GPT models for understanding and generating responses. So basically, you need to create the data with some kind of responses. For that, he says use GPT models. Within Azure, 3.5 is the free open connectivity. With
Mm-hmm.
that, a lot of people are preparing LLMs. Okay,
Mm-hmm.
so we can use in that feature also if needed. And prompt engineering is what develop effective prompts to generate accurate and contextually relevant responses based on the queries. So now, if user says, user means L1 support guy, I got this issue, that is the query. Then immediately it is going to refer to the uh, past documents, past database. Okay, then the internally we need to develop some kind of prompts also related to that particular incident description or incident category. Those prompts also need to be connected to that particular data item. Okay, that mapping need to be done under prompt engineering activity. Okay, then training is what use the processor data to fine tune the generate a model to improve its performance on its on IT support queries. Yes, this is the training activity. We need to use it after data is ready. Then integration with Azure bot services. Bot framework is what use Azure bot services to create the chatbot, integrating it with trained model. Trained model you are designing and developing here with number four activity. Okay, so in the bot framework, what you are going to do, that model you are plugging in there and giving to bot. Then there is a dialogue management required within the chatbot. Design conversation flows to handle different types of queries, including fallback options for complex issues. Okay, so all these things need to be uh, extended for further ideas or further design steps. These all are in high level actually, but we need to work on that by writing prompts and getting the detailed information. Okay, then APS, create APS to fetch relevant information from the knowledge base and historical ticket data as needed. Yes, whatever we prepared for training the model, that data need to be reused here for APS purpose. Then testing and evaluation. Performance testing is required. Test the chatbot with sample queries to evaluate its response time and accuracy. Yes, chatbot testing need to happen. Then user acceptance testing, gather feedback from actual users to refine the chatbot's performance and user experience. Here, in all these things, we can use some testing tools also to interact with chatbots also. Okay, if possible. Okay. The deployment and monitoring. Deployment is what deploy the chatbot on Azure and integrate it with existing IT support systems like ticketing systems or something. Then monitoring. Set up monitoring tools to track the chatbot's performance, user interactions, and feedback for continuous improvement. Yes, this is required. Then continuous improvement is feedback loop. Regularly collect user feedback and update the model with the new data to enhance its accuracy and relevance. Yes, this is the continuous improvement under feedback loops. Whatever improvements are required, we are going to work with model retraining, redeployment activities. Maintenance is what keep the knowledge base updated and ensure the chatbot can handle new types of queries as they arise. How come it handles new type of queries means it has got combinational data, and also along with that combinational data we trained the model already. Model has got some kind of ideas and it has got built-in prompts also. Using them, it is going to get the solutions from ChatGPT APIs. APIs connected to the chatbot setup basically. So we have ready-made prompts designed with different things to get the solutions. So it uses that, it fires, it triggers that prompts also in the backend to get the solutions. Then it is going to present to the users with reference to that. It means the process in the backend is automated with OpenAI connectivity, with ready-made prompts. Whenever we get particular word or something, I need to fix this issue. The issue name can be written by the user. Then it is going to search in the prompt. It is going to search in the database for the past incidents and solutions. It is going to pull that from either from the database or from the ChatGPT script. Then that is going to be presented in the box of the output box of the chatbot. Then tools and technologies. Azure Databricks we need to use for data processing and model training. Yes. Azure Data Lake or blob storage is used for data storage. Azure Machine Learning for model training and deployment we are using. Azure bot services, chatbot development and management we are using. Then Azure cognitive services for leveraging pre-trained models and natural language processing capabilities, we are using cognitive services. So by following these steps, you can effectively set up a chatbot for IT support that enhances user experiences and optimizes resource allocation within your organization. So this is the outcome of the bot design high level activities. What are the services we need to use? All those things. Now, the same thing, let us assume we are implementing with AIOPS, implementing artificial intelligence for IT operations practices into your chatbot design for IT support can significantly enhance its capabilities. How it is? Let us say the previous discussion happened with reference to the machine learning models. Now we are going to implement for operations this one by enhancing some chatbot features. Here is how you can integrate AIOps into existing system design. Okay, data aggregation and analysis. Centralized data collection is there. Use Azure Data Lake or blob storage to collect data from various operations sources, including logs, metrics, and events from servers, applications, and network services. Yes. So, while setting up the data collection, you have to have interfaces with the different databases from the production systems. In production, what if you see, there are network monitoring tools, there are system monitoring tools, there are log files monitoring tools. So many tools we use it. Every tool will have
Yeah.
log files. It is going to collect from the data, those log files or databases, the data collection. Okay,
Yeah.
that we are going to do aggregating the data here. Then real-time analytics is implement data bricks to process and analyze real-time operational data. Use streamlining analytics to detect anomalies or patterns that could indicate issues. That is the real-time analytics. Real-time analytics are going to be collected from the dashboard systems. You
Mm-hmm.
know, there are tools like ELK, Elastic Log Stack. Okay,
Mm-hmm.
so those tools they maintain that logs in the back end and front end it creates the dashboards. Through the
Mm-hmm.
dashboards, it can be shown to the users also. What are the current statuses of the systems? Incident detection and management, how it is. Anomaly detection, what it is. Utilize machine learning algorithms to detect deviations from normal operation patterns. See, for anomaly detection, there is a separate process within the Azure ML. We need to understand that scenario, that design also. Then we need to implement that process here. This can help the chatbot proactively identify potential IT issues and alert users to our support teams. That is the real incident detection and management. Okay.
Mm-hmm.
Automated incident creation is required. Integrate with existing ITSM tools to automatically create incidents or create tickets based on detected anomalies user queries. See, all these efforts, if you see data aggregation analysis, incident detection and management, including automated incident creation, all these activities earlier L1, L2 engineers used to create it under incident management tool. You know that, right? Now we are implementing with AI process to apply the machine learning methods uh, to automate them. Okay, see, IT service management process is what creating the incident and tracking it, following the change management process for that, right? So third one is
Mm-hmm.
intelligent root cause analysis. How it is going to do? Correlation engines will be there. How implement algorithms that correlate data from different sources to identify the root cause of issues. So, for example, if multiple users report network issues, the system can analyze logs and alerts to pinpoint the causes. So network is down. 404 error has come from the web browser. Okay.
Yeah.
Now we're going to raise the issue with the company. Then there are 100 users raised the issues. Now this
Mm-hmm.
tool, what it does, it is going to track the raised incidents for the same issues. How many users raised it? It means many users raised it means it is a red color incident. There are amber and red color, green color, like that. Different colors are there for the incidents, right? In the
Mm-hmm.
incident management tool. Okay, like severity
Mm-hmm.
1, 3, 4, like that. That level
Yeah.
of flags can be raised by the AI tool, whatever you designed for root cause analysis, that is going to escalate it under alerts. So knowledge graphs.
So
Use knowledge graphs.
what are
Yeah,
correlation engines? I have never heard of correlation engines. I mean, there are systems, yeah, there that can analyze the logs.
correlation data, not engines here we are talking about. Correlation
Okay.
data is incident database is
Okay.
there. What are the
Algorithms.
fields it
Okay.
contains? Can you tell me?
Which one? Sorry.
In the incident database, what are the fields
Yeah.
it contains?
It could contain the issue description, and then network. Usually, they attach the network trace. So, and then they will, yeah, like everything related to issue will be there. If
Okay,
there is an
now
incident. Yeah.
somebody entered one user 40
Yeah.
error is occurring when I logged in.
Yeah.
Okay, he raised the incident issue.
Yeah.
What chatbot is going to do in the back end? It is going to verify the existing database and AI prompts also.
Yeah.
Is that not
Okay.
the correlated data?
Okay. Existing database plus already the prompts that the users have given.
We trained a chatbot, right? In the ML.
Yeah.
We
Hmm.
are implementing the AI practices by using the same process, right?
Hmm.
Am I right?
Yeah.
See, we are extending the chatbot operation in the backend with AI operations, artificial intelligence operations. It is AIOPS. What is the operation
Hmm.
here? We are going to work with the incident's root causes basically. Another
Yeah.
one is we identified the incident detection. Detection can be there with small issues also. Okay, but intelligent root cause analysis comes from in the back end comparing with all those things. But manually, when you
Hmm.
do it, some incidents used to take 3 4 days also to identify the root causes, real
Hmm.
root causes, because there was a lack of tools, there was lack of
Hmm.
data for the people. Now
Hmm.
you have everything. When you have data, everything, then not obviously you need to use the tool to map it and immediately bring it up into the instant,
Yeah.
right? There is a correlated data, right, from different sources. What are the sources here? One is incident database you have provided to the chatbot. Another thing is you have provided the AI prompts to use with the open connectivity of the chat GPT. Then it runs that and gets the solution also, root cause, why it happened, all those things.
Yeah, so
Okay.
this is about implementing the algorithm that will correlate the incident data plus the
Yes,
existing
yes,
prompts to go to the root
yes.
cause.
In the backend, you might be writing Python program. That's all simple.
Yeah, yeah, yeah.
Right? So knowledge graphs are use knowledge graphs to represent relationships among incident changes and configurations. What are the relationship? The relationship is with past incidents, current incident also. You click on the URL links, it will pull the past incidents, similar incidents also. It means the reoccurrence is happening with the similar incidents because of no fix was done.
Mm.
Okay, changes and configurations as this comes under change management process and ITSM, you know that this helps the chatbot provide users with more accurate solutions based on historical data. This is the correlated data. Historical data is correlated data. Internally we are using it. Okay, then what are the predictive insights? Predictive analytics is part of this. Implement model that analyze historical data to predict future incidents and system failures. See, what you know very well, we have discussed a lot about the predictive analytics domain. You did some demo, right, for predictive analytics. Is it related to
Yeah.
what?
Predictive analytics is related to detecting a faulty system. It's more like predicting the detection of a faulty system.
So, what is the demo solution demo you have done on which domain?
Um, I have done that in the manufacturing domain. I think in the
Yeah, in
there's
manufacturing domain, you try to identify the defects,
yeah, yeah.
predictive
So
defects.
it's
If you have some issues, what are
yeah,
the other defects can come? Dependency defects or dependency operation wise also,
yeah.
right?
We try to identify the ML processes that are used for identifying or predicting based on the analytics.
Right.
That
Now the
the
same
systems
thing
that
they
are
are
defective.
using.
Yeah.
Predictive analytics is nothing but you have existing data, you have some current arrived incidents, then past data and current data, you can give the graph sheet, the predictions are these things like that,
Mm-hmm.
right? So, for instance, if a particular server shows signs of degradation, the system can alert users or IT staff before it fails. Now, you take auto scaling in Azure. Auto scaling purpose is what? If one machine is falling down, then immediately it spins up equivalent mission.
Mm.
That is the purpose of the auto scaling, to maintain the environment, right?
Yeah.
So it is predicting the machine is going to be down with some kind of uh, symptoms, mission symptoms. Maybe performance wise it is not accessible. Maybe it is not speed up to the speed. All those things. It verifies that, right, from the log files.
Mm-hmm.
Okay, from cloud logs monitoring to services there. With that, autoscale can verify that, right, in Azure.
Mm.
The same way. So capacity planning is what use predictive insights to inform users about potential capacity issues based on historical usage patterns. As obviously, the autoscale we use it not only for spinning up the replacing the defective machines. At the same time, we can increase the scaling of the environments, scaling down the environments also. So that capacity planning that need to be planned by the auto scale, where the load balancers will give some kind of hints. Network balancers, load balancers will give some hints to the auto scale. It takes the advices from that, then it spins the missions accordingly. The same way here, capacity planning is done through the predictive insights to inform users about potential capacity issues based on historical data patterns. Let us say if site is going down, then
Mm.
when site is going down, immediately they flash the message on the bank sites.
Yeah.
They might be doing in the back end the backup only, but if it is like missions are going down, at least 3 minutes before, the OS will give the alerts.
Mm-hmm.
You can put that alerts, you can set up in the system admin options. Okay, so before going down, you flash the message. That message can be flashed on the website also for the user. The systems are going to be under maintenance, they'll say. Then what
Mm-hmm.
happens? You are not going to be able to operate the site, right? Now,
Mm-hmm.
with reference to these things, we are going to work with the chatbot enhancements for AI practices implementation also. Contextual awareness, what is it? Enhance the chatbot's ability to understand context by integrating it with AI data, AIOPS data. So AI operational data we have arrived in the above tasks. We are going to use it for this input, and we are going to enhance the chatbot because we need to retrain the chatbot with reference to the latest data. It means
Mm.
when you are doing with AIOPS implementation, you are going to remodel that chatbot. After remodeling is done, you are going to retrain it. After that, you are deploying it, right?
Mm-hmm.
This allows chatbot to provide more relevant responses with reference to the above analysis, such as alerting users about ongoing incidents related to their queries. The next one is feedback loops. Implement a feedback mechanism where users can provide insights to the chatbot responses. The data can be used to continuously improve the models. Basically, performance-wise, it might be slower chatbot. That also users can enter it. Okay. Then they'll give feedback options also, like 5 star, 9 star, or something. Okay.
Mm.
Those also, as per that, if they give low rate below say 8 or 7, then reasons are going to be asked by the websites. So that reasons are going to be analyzed later. So the
Mm.
that feedback loops are very important. Okay. Then automation and remediation, automated responses for common issues identified through AIOPS. Automate responses or remediation steps directly through the chatbot. For example, if a user reports a common issue, a chatbot can provide step-by-step instructions or execute scripts to resolve them. Yes. So common issues means 404 error has come. 10 users entered it. Now chatbot it is supposed to put that into the database scanning and also AI prompt scanning. Then it will get the resolution. It will get the guidelines from that data. Then it is going to fire some particular AI prompt. Then it is going to get the step-by-step instructions to fix that issue. Now we're using Gemini, Merlin, ChatGPT extensively. If we get any issues while compiling the Terraform or Python scripts, right? While debugging, then immediately we're getting the fixes of the code basically. The same way
Mm.
it gets the solutions. You are getting,
Yeah.
because it is connected to the OpenAI. Okay. Then run books. Integrate run books that automate troubleshooting steps for recurring issues. Yes, run books are required to identify the recurring issues and compare it and give the solutions or how to control them also. The chatbot can guide users through these processes basically with run books. Okay. Then monitoring and reporting. Dashboards are required. Create real-time dashboards in Azure that visualize operational metrics, incidents, and chatbot interactions. This helps IT teams to track performance and identify areas of improvement. Normally, what happens? There are so many tools they are using, production tools. So those tools may not be having AIOPS options. But when you are using chatbot, obviously monitoring and reporting also can be inserted in the chatbot
Mm.
under AI operations. Okay. Chatbot front end, it'll ask for the user request, user inputs. But in the back end, it has got a lot of mechanisms to analyze the data and come up with a particular solution to the user,
Mm.
right? Alerts
Yeah.
and notifications. Set up alerts based on AIOps insights that notify IT staff and critical incidents and trends. The chatbot can also relay important notifications to users. It means here two ways. Whatever we have analyzed in the previous sections, steps, we are collecting the data, we are creating the incidents. Once incident is created, alert need to go to that particular developer and QA team or whoever is responsible to see that content, the notification content. At the same time, manually also this can be created by clicking something, or chatbot can be automated in the backend to create the notifications once the incidents are created.
Mm.
Okay. Then continuous learning and improvement, model retraining, continuously feed new data into your machine learning models to improve their accuracy and relevance. This includes data from user interactions, incident resolutions, and operational metrics. So basically, whatever data we are getting from users, every time new data might come, new issues might come, those need to be fed to the chatbot to LLM to retrain it. That retraining need to be activated always, continuously retrain that and redeploy it. It means
Yeah.
before retraining, remodeling activity need to be executed. It
Okay.
right? Then performance analysis. Regularly analyze the chatbot's performance in relation to AIOps insights. Adjust the chatbot's response and capabilities based on what is learned from operational data. Yes, operational data is regularly you are getting incidents information, root cause analysis from chatbot, then you are
Mhm.
getting some kind of guidelines. All the data is there. So all those are going to be shown under operational data. Okay, it is going to be learned it. We are going to train it after model is prepared it. Okay,
Mm-hmm.
Then tools and technologies what are required here. Azure monitoring tools is required. Azure log analytics is required. Azure Synapse analytics are required. Synapse is for advanced analytics and data integration. Okay, data integration can be done with Databricks, such kind of process also. Then Azure ML for developing predictive models. Yes, we are going to use it. Then Databricks for processing and analyzing operational data. By implementing these AIOPS practices, you can create a more intelligent and proactive IT support chatbot that not only responds to user queries but also enhances overall IT operations through automation, predictive insights, and continuous improvement. Continuous improvement is required for retraining, remodeling, redeploying activities. Now,
Mm.
up to this part, we have seen all the ML, using ML, how we can implement chatbot and how AIOps can be practices can be implemented with this setup. We have seen that. Now
Mm.
we are going to see how this kind of LLMs can be deployed using the MLOps and DevOps. Okay, deploying a
Okay.
chatbot for IT support. You pardon?
Okay.
Okay, we need to see that also deployment activities also, right?
Yeah, yeah, yeah. I didn't say anything. I just said okay.
Yeah, deploying a chatbot for IT support using MLOps, machine learning operations, and DevOps practices involves several key activities. What are those? Here is a structured approach to deployment phase, integrating MLOps and DevOps principles. Okay, first one is version control. Code repository.
Mm-hmm.
Use a version control system to manage code for the chatbot, data processing scripts, and machine learning models. When you talk about chatbot, we need to run the chatbot service with particular Python script. That script can be under code repository also. Then data processing scripts will be there. Okay, machine learning models will be there. Data processing scripts, why it is required? Because we will be writing some kind of SQL code also, SQL scripts also to get the data, or Python code will be there which is embedded with SQL scripts
Mm-hmm.
to get the queries. This allows for collaborative development and tracking of changes. Yes. Then model versioning. Implement model versioning using tools like MLflow or data version control to track different iterations of your machine learning models. See, model versioning is there only for ML models. Typical code, if you have Python code, code repository need to be used. The model need to be saved in this data version control under ML options. Okay, this is one of the service sub-service. Okay, then environment
Mm-hmm.
setup, infrastructure as a code you are using. Use tools like Azure Resource Manager templates or Terraform or Python in our case. Okay, to define and provision the infrastructure needed for deployment. Example: Databricks clusters, Azure bot services. These two areas are example he has given it. Then containerization, package the chatbot application and its dependencies in containers using Docker to ensure consistent deployment across environments. As if you want to deploy in different environments on different networks, you need to use it in containers. That is easy way to manage it, right?
Yeah.
Then continuous integration. Automated testing is there. Set up automated tests for your code base, including unit tests for chatbot logic and integration tests for APIs. So continuous integration is it is part of the DevOps process, DevOps activities. Build pipeline. Use Azure DevOps or GitHub Actions to create CA pipeline that automatically builds and tests the application wherever changes are made to the code base. Yes. Then continuous deployment. Deployment pipelines are set up CI/CD pipeline using Azure DevOps or other CI/CD tools to automate the deployment of the chatbot to different environments. We are going to test them on development, staging environment, production environment, pre-production environment. All those will be there, right? Then
Mm-hmm.
blue-green deployments. Consider using blue-green deployment strategies to minimize downtime and reduce risks during deployment. Okay, this
Yeah.
involves having two identical environment, blue and green, like production, pre-production kind of environments or QA testing and UAT, such kind of things. Okay, where one is live and the other is idle for updates. Normally, blue and green they call pre-production and production, which is both are similar. Okay, same.
Mm-hmm.
I can say same. for testing purpose. Model deployment is what? Model serving. Use Azure Machine Learning or Azure Databricks to deploy the trained model as a REST API. Through REST API, we are going to deploy it. This allows the chatbot to call the model for generating responses to user queries. Yes. Model monitoring. Implement monitoring to track the performance of the deployed model, including metrics like latency, accuracy, and user satisfaction. Use Azure Monitor or Application Insights for this purpose. Yes, that is there. Then integration with Azure Bot Services. Chatbot deployment is there. Deploy the chatbot using Azure Bot Service. Ensure that it is properly connected to the backend services and APIs. Yes, we discussed about the open connectivity with ChatGPT, OpenAI, APIs, open APIs. Okay, that is part of the chatbot deployment, including the machine learning model and any databases, whatever is related to this chatbot services. We used it. Okay, then webhook configuration. Set up webhooks to handle incoming messages and route them to the appropriate services for processing. Let us say on the web browser or on chatbot window, people are typing it. Then one webhook need to be there to receive and send direct to that particular database. Okay. Then the webhook need to be categorize the data related to which database also. Then it need to fire that particular Python script which contains the SQL to insert this data in the database with the insert option of the SQL, right?
Mhm.
Then monitoring and logging. Log management is what? Implement logging for the chatbot to capture interactions, errors, performance metrics. Use Azure Log Analytics to analyze logs for insights into Azure behavior and system performance. Okay. So that is the one we are going to do here. Logs management. Alerting is set up alerts for critical issues such as model performance, degradation, or system outages using Azure Monitor. Okay, so monitoring logging need to be implemented as part of the deployment. User feedback loops. Collect feedback is what? Implement mechanisms to collect user feedbacks on chatbot interactions. This feedback can be used to refine the model and improve responses. In the previous sections also we have discussed about the feedback loops. The same thing we are implementing here. Retraining pipeline. Set up a pipeline to periodically retrain the model based on new data and feedback. Automate this process to ensure continuous improvement. Yes. Then documentation and training. Documentation is what? Maintain comprehensive documentation for the code base, deployment process, and operational procedures. This helps onboard new team members and ensures knowledge transfer. Yes, obviously. So whatever you are updating it, every version of the model need to be documented to retrain the people also, not only retraining the models, right?
Mm.
Then training, conduct training sessions for IT support teams to familiarize them with the chatbot capabilities and how to escalate complex issues. Okay. Then security and compliance, access control, implement role-based access controls (RBAC) and ensures that only authorized personnel can access sensitive data and deployment environments. Yes, identity access management roles need to be used it here. So data
Mhm.
privacy and compliance ensure that the deployment adheres to data privacy regulations like GDPR, HIPAA in case of healthcare, such kind of thing, by implementing necessary data handling and storage practices. So
Mhm.
what are the tools you can use it? For CI/CD pipelines and project management, Azure DevOps you are using, and Azure Machine Learning is for model deployment and monitoring. Docker you are using for containerization of the applications. It means you are
Okay.
creating the images, okay, for
Mhm.
redeploying. Terraform and ARM templates or Python script is IAC. Azure
Mm.
Monitor and Application Insights for monitoring and
Mm.
logging. So by following these deployment activities, you can ensure a robust, scalable, and maintainable chatbot solution that leverages MLOps and DevOps best practices. This approach not only streamlines the deployment process but also enhances collaboration between development and operations teams, leading to faster iterations and improved systems reliability. So that's where it comes here. That is the end of the project design plan, basically. You can say This is a chatbot development for IT support plan. Okay.
Mhm.
Now you got some clarity, right, about this?
Yeah.
Wow, it did not record it. Huh? Oh, it stopped. Okay, it is recording. Stop.